Here we have a SAT math problem. Okay, let's go to the question. In the given system of equations, k is a constant. If the system has no solution, what is the value of k? In the given system, both the equations are linear. Okay, before we start working on the problem, let's consider a concept. Let me consider a system of two linear equations in standard form. That is a1x positive b1y equals to c1. This is a linear equation standard form because we have x term and y term on one side of the equation and constant on the other side. Let me consider another linear equation standard form, that is a2x positive b2y equals to c2. Here we have a system of two linear equations in standard form. Let me get the ratio of the coefficients of x, that is a1 over a2, and the ratio of the coefficients of y, b1 over b2, ratio of the constant terms, c1 over c2. If this system has no solution, then the ratio of the coefficients of x and the ratio of the coefficients of y will be equal, and these two ratios will not be equal to the ratio of the constant terms. Since the given system has no solution, we can apply the stuff what we have discussed over here in the given system. But before that, we have to get each of the two equations in the given system in standard form. And also, we have fractions in both the equations. First, let's get rid of the fractions so that it will be easier for us to do calculation. Okay, when I consider the fractions in the first equation, we have three different denominators, 8, 5, and 7. Let's find the least common multiple of the three denominators, 8, 5, and 7. Is there any common divisor for all the three numbers other than 1? No, there is no common divisor. At least for two of these three numbers, is there any common divisor other than 1? No. Then we have to multiply these three numbers, that is 8, 5, and 7. We have to multiply the three denominators to get the least common multiple. 8 times 5 is 40, 40 times 7 is 280. So 280 is the least common multiple of the three different denominators we find in the first equation. Now let me multiply both sides of this equation by 280 to get rid of all the denominators. Okay, let me do it. That is 280 times 3 over 8 times x positive 7 over 5 times y equals to 280 times 9 over 7 negative 7 over 5 times y. Okay, now we can distribute this 280 to this 3 over 8 times x and also to this one. Okay, when I do distribution of this 280 to this one, we can simplify this 280 and 8. That is 8 goes into 8 one times and 8 goes into 280 35 times. Then when I multiply this 35 and 3x, I am getting 1 of 5x. That is when I multiply this one and this one, I am getting 1 of 5x. Okay, when I distribute this 280 to this one, we can simplify this 280 and 5. That is 5 goes into 5 one times and 5 goes into 280 56 times. When I multiply this 56 and 7y, I am getting 392y. So when I multiply this one and this one, I am getting 392y. Now let's do the same thing on the right side. So we can simplify this 7 and 280. That is 7 goes into 7 one time, 7 goes into 280 40 times. 40 times 9 is 360. Okay, let me write over here, negative. Now we can simplify this one and this denominator 5. That is 5 goes into 5 one times. And 5 goes into 280 56 times, and when I multiply 56 and this 7y, I am getting 392y. Let me write over here. Okay, now we have x term and y term on the left side, but still there is one term which contains y on the right side. Okay, let me add 392y to both sides of this equation. Okay, then this negative value, positive value will cancel out. 1 of 5x. When I combine 392y and 392y, I am getting 784y. On the right side, we have 360. We have x term and y term on the left side and constant on the right side. I got the first equation in standard form. Okay, now let's do the same thing for the second equation. So we have to get up the denominators so that the fractions will be no more. We find two different denominators, 4 and 3. The least common multiple of 4 and 3 is 12. Let's multiply both sides of this equation by 12. That is 12 times 5 over 4 times x positive 9 over 4 equals to 12 times ky positive 4 over 3. Okay, here when I distribute this 12 to this 5 over 4, we can simplify this 4 and 12. That is 4 goes into 4 one times and 4 goes into 12 3 times. 3 times 5x is 15x. Okay, here 4 goes into 4 one times and 4 goes into 12 3 times. 3 times 9 is 27. Let me write over here. And 12 times ky is 12 ky And here 3 goes into 3 one time, 3 goes into 4 times, 4 times of 4 is 16. That is, when we multiply this 12 and 4 over 3, we get 16. Okay, here we have a constant term, and here we have y term. So we have to get the x term and y term on one side of the equation, usually on the left side and constant on the right side. Okay, let me subtract 12 ky from both sides of this equation, and also subtract 27 from both sides. When I do so, this positive value, negative value will cancel. The same here, we get 15x negative 12 ky equals to, and when I combine this positive 16 and negative 27, I am getting negative 11. Okay, now I got the second equation in standard form. Since we got both the given equations in standard form, we can use the stuff we have discussed over here. Let me get the ratio of the coefficients of x, that is 105 divided by 15. Now the ratio of the coefficients of y, that is 784 divided by negative 12k. Okay, let me write it, 784 divided by negative 12k. Ratio of the constant terms are 360 divided by negative 11. As we have discussed over here, that is when we have a system of two linear equations in standard form and the system has no solution, the ratio of the coefficients of x, the ratio of the coefficients of y will be equal, and both these ratios will not be equal to the constant term. Okay, since we have these two ratios are equal, we can solve for k in this equation. Let's do cross multiplication. That is, the numerator on the left side has to be multiplied by the denominator on the right side. Then I'm getting 105 times negative 12k, and the numerator on the right side has to be multiplied by the denominator on the left side. Then I'm getting 15 times 784. Okay, when I multiply this 105 and negative 12, I am getting negative 1260k. On the right side, when I multiply this 15 and 784, I am getting 11,260. Okay, my aim is to solve for k. Let me divide both sides of this equation by negative 1,260. Let me do it. Okay, so here this negative 1,260, negative 1,260 will cancel out. I'm getting k on the left side. On the right side, since we have a negative sign for the denominator, we can consider this negative sign for the complete fraction. And we can get the simplified form of this fraction using Desmos. When I use Desmos, the simplified form of this fraction is 28 over 3. Okay, here I got the value of k, that is negative 28 over 3. So if I want to get this, get the value of k as a decimal, I am getting a very long decimal, that is 9.3333. It keeps going, that is negative 9.333, but we can keep the value of k as a fraction, that is a negative 28 over 3.